Greetings everyone, I'm Anurag from the marketing team of Institute of Information Security. This webinar has been brought to you by IIS and I welcome you all to this webinar on cryptominer malware analysis. So without further ado, I'd like to introduce today's speaker, Mr. Sudhendu. Over to you, Sudhendu.
Hello folks. Today we are going to see about cryptominer malware analysis. Is cryptocurrency mining malware the new adware? So these were some this was a question that arose, you can say, in the late or fall of 2017, because 2017 was the year of malwares. You have seen WannaCry, Petya, NotPetya, and whole lot. So, well, whatever we can say or whatever the critics say, it is clear that we are really in the midst of a digital gold rush. Whatever, Bitcoin, Monero, Ripple, Ethereum, so whatever they are. So there are different, many kind of cryptocurrencies have exploded in quite of recent in values in these recent months. So, like for example, if you take Ethereum, so it has skyrocketed from $8 at the start of 2017 to around $300. You know, so similarly, there are a couple of other cryptocurrencies, and if we say like the total market capitalization of cryptocurrencies, it literally jumped from you can say like some few million to like literally $19 billion in just 8 months. So it's not only just about the geeks or techie investors who enjoy these kind of thing. So this has been really taking up into the market. So that's why this thing is what you call in the boom. It is booming now. So basically, before I go toward, so today what we'll see is like about what is a crypto miner. So what it does, what it affects. So basically we say it affects cryptocurrency, and what is a malware, and like the analysis, malware analysis, what it is, and malware analysis of the crypto miner. So before we go towards different details and stuff, so let's first start something about me. So well, I am a security enthusiast and a researcher. By profession, I am a trainer and an analyst. I currently work at Network Intelligence India, NII, and Institute of Information Security, IIS. I am a geek, yeah, a hardcore geek. I am a tech savvy person. I dwell in industrial control systems, ICS securities, IoT, Internet of Things, robotics. Yeah, that has been part from my college life, from my time of graduations, and even like high schooling. And yeah, I also dwell in digital forensics and incident response. So more into forensics. Forensics has always been a part of my interest. So for basically by education, I'm an electrical and electronics engineer. And yeah, I like about my work also, like I have been also I have done my certifications and trainings at IIS, and now I'm working here. So yeah, if you want some really good thing to learn, get into the infosec, this is, I would suggest, it's a good platform. So these are my some contact handles, like my Twitter handle and my LinkedIn handle. Okay, so I think that's pretty much about me. You can say I'm just on a what account analyst and trainer in the day, and do my ninja and research work at the night. Yeah, robotics and anything related to even cosmos and stuff, they all interest me. So Moving on to cryptocurrency. So basically, let's we know that what let us know like what is exactly a cryptocurrency is. So cryptocurrencies, you must have learned if I tell you what do you call Bitcoin. So recently, like everybody has been, there has been a big hype for Bitcoin and other slowly different kind of crypto coin. So we can tell these are some digital coins and digital currency systems, right? Okay. So if we go by starting from these currencies, cryptocurrencies are basically built on blockchain technology. So but many would so generally think like what is blockchain, like what are all different jargons I'm speaking. So folks, do you think like what it is, like our 21st century Sphinx unicorn currency of future? Well, undeniably, this is an ingenious invention, and it is like it got its birth from cryptocurrency, which is the brainchild, it got its birth from blockchain, which is undoubtedly the brainchild of the pseudonym Satoshi Nakamoto. Cryptocurrencies are built on blockchain technology, and blockchain technology is generally essentially a distributed and decentralized ledger. So, blockchain, you can say like anybody who have heard about it generally have associated it with the most famous cryptocurrency Bitcoin. But again, let me tell you, blockchain has evolved into far more greater and powerful concept by allowing digital information to be distributed but not copied. Blockchain technology has created the backbone of a new type of internet. So you can say it's like a spreadsheet that duplicates thousands of items across a network of computers. This network is specially designed to update this spreadsheet regularly. So uh, you can say like what you can say like it's something you can associate it with Wikipedia kind of thing, but no, it is not like that. Like if you are seeing it from some cruising altitude, yeah, it not may not look like something much different with Wikipedia. Like if we go to like see from a proper root level, so then we can only see the differences between blockchain technology. Well, this both, like you say Wikipedia or any kind of encyclopedia, the both run on distributed networks that we call the internet. Wikipedia is actually built into what we call the World Wide Web, that uses your general client server network model. Generally when user access this Wikipedia page, they get the updated copy of the updated version of the what you call the master copy of the Wikipedia. But the distributed database created by a blockchain technology has a little fundamentally different digital backbone. So this is really the we can call say most distinct and important feature of blockchain technology. While your other system like Wikipedia, they have control of centralized database. Blockchain, it lives something on what you call the decentralized backbone. So it has decentralized database system. So what we can say is like here transactions are broadcast, and like every node, so every node is creating their own updated version of events. So it is this difference that actually makes blockchain technology so useful. So it generally represents, or you can say, an innovation in information registration and distribution. So and that eliminates the need for a trusted party, to facilitate a digital, what you can say, relationships. Yet it's like this may some to some this may like look at something new, but trust me, it is not a completely new technology. Rather, our engineers like it's something that is, we can say, orchestration of three technology that the genius Satoshi Nakamoto, no, that we attribute it to. So it's generally where you also it's orchestration of three technology like the internet, private key cryptography, and the protocol governing incentivization. So this is what made Bitcoin creator, like, Satoshi Nakamoto's idea, like literally so useful. So uh, what another thing that what you can say about this blockchain is like it's this blockchain, it lives in a state of consensus. It's one that automatically checks in with itself every 10 minutes. It's kind of like a self-auditing ecosystem of digital value. The right. So and the network reconciles like every single transaction that happen in 10-minute intervals. So each transactions group is generally considered as a block. So we saw generally as like what digital currencies are. So yeah, blockchain generally it works as a digital ledger that keeps a growing list of records called blocks, what I already told you, and like all transaction that takes place across a P2P network. So basically, blockchain it started off with this P2P network, and if we call it generally it was like for if anybody knows, so it came it and on origins from the gaming. So generally these all things came from gaming, right? So more importantly, you can say like it defines a digital trust. So generally what you call trust is a risk judgment between different parties, right? And in digital world, determining trust often boils down to like providing identity, what you call, and like proving or giving authorization. So we can say simply like are you the one, or are you who you say you are, or like should you be able to do the thing that you are trying to do or you are doing, right? So in case of blockchain technology, this private key cryptography, that one of the three things what I told that comprises block, that is the root of blockchain. So it provides a powerful ownership tool that fulfills this authentication requirement and all these things, right? So I think pretty much we have got about like how this like what is blockchain, and why exactly, like what is the thing behind the cryptocurrency, what is blockchain, and what is the cryptocurrency thing is. So here we see like each transaction between members need to be verified and validated by members. So we'll come up to this mining thing, but before I go for the mining, so let me tell you something. Like, see, no, there are generally two important properties that result from this, transparency of blockchain. So that is like what I told how this blockchain works. This concession system of network. So that is one. That transparency data is embedded within the network as a whole. Now, by its definition, it is a completely public, what you call a public. So now you can say blockchain are evolving into public, consortium, and the private systems. But generally, what you say, it's the cryptocurrency case is generally the public one. and also that it cannot be easily corrupted by altering any unit of information on the blockchain. See, theoretically it's possible. Yeah, trust me, theoretically it's possible, but practically it's something like it means that you are using something huge amount of really huge, what do you call it? In the titanic amount of computing power to override the whole entire network. And I don't think any person or any small group is that powerful over the whole computing power of the whole internet. Now, is anyone? I don't think so. Oh, otherwise, like you'd be something like a medieval king kind of like who ruling a whole entire continent and having the whole computing power. And that if we are in that case, then yeah, we are certain in a digital war. So well, even like it is really unlikely. So practically, we don't think this would happen. Even if it would happen, then it would also mean that the effect is will be that destroy the value of the cryptocurrency. So, for example, like if someone is trying to take control of the whole system to capture Bitcoin, then they would also have the effect of destroying the value of the Bitcoin, right? So about now we before we go about now this earlier I told you about this authentication and legitimizing the thing. So what this involves in this Bitcoin is like proving or what you call the proper authenticating of the no this blockchain values and stuff. So what you can say is like Bitcoin mining. It's generally so this process what we do we like to each transactions like different members need to be verified and validated by some members of the network, and this is what we generally call no this is generally done and by the mining. So what I can say is like Bitcoin mining, it's generally the process of authenticating and legitimating Bitcoin transfers done online, right? And it is in a you can say in a simpler scenario, if you can say just imagine the teller in your bank, maybe a digital teller or person whatever, who authenticates a deposit or a withdrawal transaction that you may make by physically visiting the bank. So in the world of the as yet unregulated cryptocurrencies, every single transaction or exchange made using these cryptocurrencies need to be added to what is known as a final Bitcoin ledger or blockchain. So see, so these transactions when they combine, so then they reach the status of block, what I defined earlier, like what is a block. So and it is this block then that is generally sent to the miners, generally the people who verify or validate it by different blockchain networks. So they have different, so if you are Bitcoin, if you are using a Litecoin or Ripple or whatever, and what we are going to listen, what we are going to see or analyze today, that's about in our case it's Monero. So generally what these miners do, like when they miners they receive these kind of blocks of data, so they need to be mined. So mind what you can say using specialized hardwares, and so what generally do they use this called of hardware and key. So they have to use this key, special keys called nonce to encrypt the block of transaction data. So now this hash is then added to the block that was received earlier, and then therefore so it authenticates it. So miner generally, so how the people say the mining and mining. So how generally, like why do I do mining? And what's exactly do I get from it? So see, so when you generally this the way I define the block is generally complete a block, complete authenticating a block. So that is how they generally receive the amount. So when they complete a block, they generally after that they are paid based on, like, if they are going on Bitcoin, they will get Bitcoin. They were doing Litecoin, Ethereum, Ripple, whatever they use, they're similarly. So it is so Bitcoin miner, you can say in a generic way, it's a peer-to-peer computer process. So what we use to secure and verify now what kind of Bitcoin or whatever cryptocurrency transactions. So that is the payment one peer does to another on this decentralized work. So like the main thing is like you can see like during this last quite a couple of years, like an incredible amount of mining power, what you call hash rate, has come online. So it's so what the result, it makes it really harder for individuals to have enough hash rate to single-handedly solve block that I discussed earlier and earn the payout or on the reward. So to compensate for this, so people try to do different kind of thing. Like for example, a legitimate method is pool mining, and some go for this what you call cryptocurrency mining malwares or bots. So generally what the pool mining is, it's a mining approach where groups or individual miner generally to contribute to the generation of block and then split the block reward among, like, how much so who has what do you call contributed. So this is so this is what generally mining is about, right? So moving towards, like, this was about so like I said, so generally yeah, and yeah, so these kind of things like a hash rate where you already got, so these thing what you call a generic term, like it involves a number of complex mathematical calculations. And obviously, like huge calculations, so you need huge computational power. And what does that mean? So if you are considering huge computational power, so that means you require a huge amount of resources, right? So you can say that this thing operate independent of any kind of central authority, trust-based, peer-to-peer, as I said, that is peer-to-peer consensus. So this all thing, so it gave to rise of two things, like I said, a pool mining, and another is like the easy way, like the people with evil intentions, our so-called hackers. So they this discovered, so rather than we doing these kind of different things, from they generally got the idea from the pool mining only. Like say we are 100 guys and we are 100 or 100 people, we are 100 people doing this mining stuff, and generally say we get as low as like something what you call $100. We did a little work and we got 100, or we got 1 grand, so $1,000. So rather than distributing this $1,000 among 100, so getting individually, like I spent days and just got $10, what if I get the whole of this $1,000? Isn't that sweet? Yes, indeed, it is a sweet enough. So then how can I get that? Like I need the power of these 100 people, 100 computational power to obviously to like mine that much what I did for this $1,000, but I am not ready to share them. So the solution came as the mining bot or the mining malware. So what they started to do, so they relied on successfully infecting a machine, right? And these machines that like this, so I tried successfully infecting the other 99 machines in the pool of our 100, and these 99 machines will no, they will silently mine They silently they will go on what you call, they do the mining stuff based on whatever the instruction I gave, like a code, some script, whatever, and they will do the task that these like we 100 in a pool used to do. And the good thing is that the people won't know like their resources being consumed, and the whole 100 thing, it is just like I used this 100 resources and did the mining. So you can see the earning that this 100 computing resources yield will be whole to mine. So that is one of the main reason people use this kind of Bitcoin mining. But again, I'm telling you, Bitcoin mining is, it's not illegal. But yeah, doing this in the way like I said, explained now, and this malware and using a botnet, yeah, it is illegal. So you can see, and one may ask like why, if you are not, I suppose like almost are aware, but if we see, so this is some value I had like collected while I made this slide. So you can see like one BTC, that is that representation of Bitcoin, is around more than $14,000. So can you just imagine? Like just mine, if you just mine one BTC, you are getting $14,000. So just imagine like what is the power of the currency. And the another that we are going to discuss today is Monero. So one Monero is around some $520. So you can see this looks quite sweet, right? It's quite I think explaining this elucidated doubts, and I think yeah, people would be like, wow, yeah, this is something I need. But again, no using of bots, right? Okay. So what I can say is like what we are going to discuss today is about malware that is known as adelkas, right? So what generally this adelkas is, so it's generally no it's generally a malware that was like that mines Monero. So before explaining you to this, so let me tell you, like around in May, so in the 2017s, so attackers they generally spread a massive ransomware attack worldwide. And if I tell you the name, you can generally recognize it because it literally made everybody cry. Yeah, true. It's indeed the one known as WannaCry. So that ransomware, it spread the worldwide using Eternal Blue exploit to rapidly propagate the this itself over corporate LANs and wireless networks. So Eternal Blue, it was originally exposed as a part of the shadow brokers dump of NSA hacking tools, and it leverages a vulnerability in Microsoft Server Message Block SMB on TCP port 445 to discover vulnerable computers on a network, and it literally laterally spread malicious payloads of the attacker's choice, so whatever they used to paste using this exploit. And what the also it was coupled up with another NSA backdoor called double pulsar. So the attacker used the exploit known as Eternal Blue that can easily exploit the SMB in my MS Windows, and they used to put whatever payload they want, and then again along with that they used to install a backdoor called double pulsar to actually install the ransomware, what they call the WannaCry. But during those times, so it was slowly and slowly observed like a very large scale of attack using both internal blue and double pulsar was going on. And how come they saw is like some these attacks were going on, and oh, they use some statistics, and they saw like there was in maybe in larger scale than WannaCry, there was some attack which resulted in shutdown of SMB networking to prevent any kind of further infection with any other malware, right? And that it may in fact have limited the spread of WannaCry. But there was other effect, and that is like after the systems were or servers were affected by this attack, even though they were stopped from being infected by WannaCry, but they began having severe resource consumption issues. So now so severe resources were being consumed in them, and we saw some really degradation of PC and server performance. And later and also there was no kind of ransom notices. So now people tried and they find out, yeah, this is associated with some kind of other malware, and that was Adelkers. So it was a cryptocurrency mining malware, right? And it generally what it did, once it get in, it tried to close off this SMB so that no other infection like WannaCry could come. Otherwise it would have lost its purpose, because if the system goes, then it is no use for this Adelkers, and it kept on using the resources of the system. And so we can but if you look out, generally the campaign of this Adelkers, it even predates WannaCry. So even though WannaCry was happening in May, Adelkers was even from starting from around March and April it was going on, even though it was less flashy, because ransom, there was no ransom. WannaCry asked ransom, so everybody was knowing, because until and unless you are popped up with something, people don't know. Yeah, that's true, many people are there out in the market, they don't know. If your resources even come from why my system is getting slow, nobody would dare to even think, yeah, it's maybe the malware attack or not. So while only researching the WannaCry campaign, it was exposed about this cryptocurrency miner that is known as Adelkers. So going on to the malware analysis part, what is let's understand like what is malware analysis. And before that, let's know what is exactly malware. So malware is nothing from, it's just a malicious software. And by malicious, I mean anything that harms the computer, no, to harms the computer, server, whatever, the user system. So that is a malicious software. So it may include a different type of malwares, what you call known as, generally people associated with virus, but no, there are a couple like virus, worms, Trojan horse, spywares. Yeah, you see spywares in this business rivalry. So what they do, so maybe they corrupt your system, they maybe delete, or in the case of what we saw in the WannaCry, it may try to encrypt your data, or threaten you about deleting and ask you some ransom. So what we call the ransomware. Or they keep on hijacking your core computing functions, or without your permissions. And it's like if or something like self-executing that spreads and infects your other application like virus, or replicating malware or software that without a host programs then will spread without any human interactions, or any directory from malware author. That is what you call a worm. A Trojan horse, anybody who knows about a Troy story, or the Greeks, they know about what is a Trojan horse. So something that hides behind a legitimate software or program, and once you install or activate that legitimate software, behind it will get no activated, and hideously they will execute their malicious functions. And yeah, spyware generally people used to recon, do gather what kind of different informations. Generally in business rivalry and stuff, people also some do. I shouldn't tell this, but yeah, it is a fact. Some people try to, the black hats, they do to spread and try to see if they find any kind of loopholes and any easy targets. So there are a couple of other malwares are there. So like some backdoor virus or some remote access virus. So this was all about malware. So now malware analysis. If uh, we are going about malware analysis, so can we just see like what is generally the malware analysis? So this is all about malware, right? So let's see exactly what is malware analysis. So malware analysis is generally what you call, so when you analyze something, what do you do? So we can say just dissect something. When we do different kind of product analysis, or we do any kind of application analysis, we generally dissect it. What we reverse engineer it, we see exactly what it does. So the reason is, so we have to know three things mainly, like how it works, how to identify it, and like how to defeat and eliminate it. These are the three main things that um, we know the answer to which is the malware analysis. Like, or you can say like this is the three things to know which we do malware analysis. So malware analysis involves like couple of different processes to do. We what you can say, we have to different kind of things we do. So so a basic malware analysis, you can say, is so knowing the functionality and like what are the potential impact. I will say that these three questions are the one thing that we need to know. So what is, why then, like after we know, like yeah, these are the process of malware analysis, but have you ever asked like why we need to do even the malware analysis? So these are something to provide information to respond to a network intrusion, of course. Then what to, like why do we need even, so we need to even know like what is the extent of the damage, or even assess it. Like if it's about the pre-attack, if you say my good friend is like by no, we can say got infected, and he shared his knowledge or information regarding the malware to me, then I can assess like what is the extent of the damage only if I know the malware, if I've analyzed the malware, and I can prevent myself from getting infected by that malware. Or one thing I can do, or I can know like what are the steps to take so that I can minimize the effect or the damage that the malware can cause. Another thing is like to identify the vulnerability. Yes, if malware is trying to exploit something, then I can also know, yeah, this vulnerability it uses, so this is the vulnerability that I should patch. Also, we have to like determine like what it can do, like how it behaves on the network, what it can contain, what it can disinfect, what it is targeting. We can learn different things. AV companies, they try to know, like yeah, if malware is some signature based, like can we stop this malware by adding some signature, or is this no, so that in our network this malware never comes, so we just develop a signature to detect it. Or we can say some check some behavioral based. So there are different malware, like in case of fileless malware, you can't just use and store this malware, so you have to developing signatures is really difficult. So we can develop some signatures, and then we can see, yeah, okay, so let's the signature, or you can see some behavior based. and we can say okay, so let's do this that, or what is the procedure that's needed to do, and then we can know more about the malware. So this is generally the reason what we call the malware is done. Okay, now generally basically we have two kinds of malware analysis. One is the static analysis. So as the name suggests, so static analysis involves generally what you can say, without executing the malware, without running the code. You don't run the code. You don't no, no. Actually, you don't just identify whatever the header it has. Use the tools like the file tool, and no, I didn't. If you're in Linux or some, you can use your file command and check about like whatever the file attributes are. You can run strings on the command on this malware and see out like whatever the string value is, does it contain. You can use a disassembler like IDA Pro or other, or Binary Ninja, some other are there. Check out exactly what the code is. You can run the pp values. You can check about different kind of, generally what I mean is like performing in a non-runtime environment. So it will generally, you have different tools that will inspect the program code, check for different P's and like different runtime behaviors, and like check if there are some backdoors or some coding flaws are there, or some malicious code is there. Yeah, some malicious code, and based on some signature it can check. And the other is like dynamic analysis. So it involves just opposite, as the name says, dynamic means some action, right? So it involves executing your code in some control environment like sandbox or virtual VMs, virtual environment, and that is generally unlike the static analysis. It adopts the completely opposite approach and executes the the program. So generally what it will test, so it will test your system memory. So it will check about the functional behavior you can't get in the static analysis. You check the response time and the overall performance of the system. So this is not quite much dissimilar, what you can say, from so no static analysis, or in the much manner in which malicious third party may interact with the application. So why are these two methods? So why can't we just use one or no? So see, there are some strengths and weaknesses of both the methods, right? So if we say about static analysis, it's completely, which is white box visibility. It's obviously certainly the even the more thorough approach, and you can say like you are also safe approach, and oh, what you can say, like it may also prove more cost effective with the ability to detect bugs at early phase of the software development life cycle. So it's before even the software can be run, you can just at the initial stage you can check the code, you can run you can read about the P's, you can analyze it, and you can know about it. So for example, if an error is spotted at sometime at a meeting or reviewing or something, so both type of analysis, say a static analysis, say like it can be no, what you can say, what I mean to say is like if the error was spotted in the review timing or in the review desk only, it can be easily, the remedy can be done easily and it would be cheap. But just see if the error had been logged to the system, and then you come back or you drop a ticket, and then you could find some remedy for this I can say this error, so that the cost and the time spent would be more. So obviously you can see static analysis can also help you, like, yeah, if this is the code, then certainly it may lead to these errors, or these vulnerability, or these flaws. So, and the thing is, like, for static analysis you need to be technically quite strong. So, and it what you can say, it is kind of some may say, like, it really, so doing a static analysis and somebody is really finding everything in their static analysis, then it's also a superior method of testing. It does not necessarily follow that it should automatically be chosen over dynamic analysis in every situation. So I would say, like, there is no best, like, you can say, you can't say like static is best or dynamic is best. Depends on your whatever the thing to be needed, you can say, like, when or what is needed. So yeah, at some point you can say static analysis is good. So for say, if in your system, it's a Linux system something, and you're not, or in your system you're not allowed to run any executable, and something has like a Trojan, somebody has shared you some file, and you can see by doing some static analysis you get to know like some a process executable is hidden behind it, then you'll directly jot it out. So in this case, this simple analysis helped you to stop that file from executing. You don't need dynamic analysis to analyze the behavior, and like, why take the risk. So it all comes about, like, what your need is, right? Another good thing is, like, generally two things we use, that is the disassembler and debuggers. So disassemblers are generally used for static analysis, and the reason is, like, they are just to disassemble the code, and they don't allow executing. However, in case of debuggers, like, we have some common, like OllyDB, immunity debugger, and win debugger. So there are a couple. So in those case, the program code can be debugged, right? So you can change, you can edit, you can what you can say, you can execute. So you can just in a simple term, you can say a disassembler is generally a tool that transforms your machine code into human readable, but your debugger, no, it allows you to change the running state of the program. So obviously in dynamic case you generally use a debugger, right? So now coming to static analysis. So we have, like I told you, so file command. So using file command, say for example here I've done is like a file and run on a PDF. So you see, so just like, yeah, the format is PDF document. Even if I don't put it .pdf, I change to something else, still if I run the file command, and if its property attributed, yeah, it's a PDF document, it will show me PDF document, right? So I have run it on an exe executable file, and it showed me, yeah, it's the P30 executable, and it also telling you, yeah, it's a GUI system. Another good is, like, generally you get some URL, you can, or some domain info, or some any kind of hard-coded info you can get, that is using your strings command. So you run strings command on anything, and say for example I have used, this is for filtering purpose, grep. Anybody who has used Linux, they know. So I grabbed out HTTP, and I found, like, in this executable, these are all the links that are hard coded into it. So these are all the URL that I get. So similarly in the malware, sometimes you get some keys, sometimes any values or any DLLs, different kind of important fact or artifacts we gather running this strings command. Okay, so about the P data structure. So static analysis really involves the knowledge of the P data structure. So P data structure generally contains all the information that are required for your Windows OS loader to manage and execute the code. And what I can say is like generally the portable executable, what you call portable executable file, so it's a type of file format, so that is generally used in both 32-bit and 64-bit Windows. So and it's P file format. So it's so the P data structure. Before going P data, let me tell you P file format. It's a data structure that contains your information, as I said, for required for Windows OS loader to manage the executive code. So there are a couple of things like R data, dot data, resources. I will come into it. So before going to all that, so generally our a P executable, a P file, a P executable, it generally contains two sections, and that is generally subdivided into a couple of several other sections. So one is your header, and the other is the section. Yeah, the other section name is section, right? So what the header, so the header is generally it has a couple of things in the header. So one is like a DOS header. So DOS header generally it starts with what you call the first 64 bytes of every P file. It is the DOS header. So it is there because you can say like DOS can recognize it, like yeah, it is proper executable. It can validate it, right? And can run it in the DOS stub mode. And what I can say is like this generally, what is the DOS stub? So DOS stub is nothing. It's just generally the first part of the Win32 executable. Eh, and and there's just one small requirement, like and at offset there is a D words, generally that specify the start of the P block relative to the start of the file. So basically what you say is like you can just put any DOS execute program in there, and as long as you make sure that there is room for the D word at offset, whatever the offset that is in the file, so it's all perfect. So usually this is no problem, since the executable exe header itself is usually quite big and a lot of the space is not being used. So Microsoft, it has its own stuff and it has an empty header mostly, and the code starts right after the D word. So yeah, we can investigate this and get some information. So one, you can say like there are a couple of tools that I'm going to use. So as you can see, there are like tools like CFF Explorer, PEID, PEStudio. So these are different kind of tools that are there that we can use for doing the analysis of static analysis. So I will come back to it. And I think it would be better when doing this kind of thing. I will explain you, so you will be giving like you will have a more better idea. So I will explain those in the demo time, right? So coming to next is this tool PEStudio. So the PEStudio, so it's generally used to statically analyze malware. So file is actually never executed. I have already explained that in the static analysis. And it uses a powerful parser. It's a flexible set of XML files and like that are used to detect various type of indicator. There are a couple of things in it. You can directly connect it with the virus total. You can see whatever the values the virus total can give. You can check the DOS stub. You can check out the file header. You can see the directories, libraries, and a couple of things. I shall show you while doing the demo. So coming to the dynamic analysis, see, like there are a couple of tools like I showed you. So one was like it's a PEStudio, the other is like CFF Explorer. And there are, if you go and search in the GitHub or in the internet, you can find a whole lot of like different tools for doing this kind of static analysis. So dynamic analysis, as I have already discussed, it involves your code execution, so doing something dynamic, right? So these are a couple of some tools. So you have ProcMon, sorry, there's a typo error, it's not ProMon, it's ProcMon. You have ProcessHacker. So ProcessHacker, you can say another good tool on replacement to your sysinternals process explorer. You have regshot that takes a snapshot of your registries. We generally use it to gather the snapshot of registry before the malware infection and after executing the code. We have AutoRuns, CaptureBat, and FakeNetNG. So FakeNetNG generally it's a really good tool. It's by FireEye Inc. And what it does, it allows the creation of a fake network and diverts all traffic that our system is trying to generate to the local host, and it captures everything there, monitors everything, and records into a PCAP file that we can later analyze using some network analyzer tools like say T-Shark or Wireshark. I think everybody would love Wireshark more. People love GUI system, graphical user interface. Okay, so we have these, you can say, so ease of use for now for all the abstraction level you have. So you have diffing, you have file registry process, network monitoring, API testing, debugging. So these are all generally a procedure for dynamic analysis. Okay, so ProcessHacker, it's really powerful tool. It's multi-purpose. You can see whatever the different processes are going on. You can check out what are the address or the remote connection it's trying to generate. You can properly get the socket rate, socket value. You can check the rate at which it's trying to different kind of transfer rate or data access rates. You can see what the firewall status is there. You can check out for services, you can check out the network, you can check for disk, whatever you all can. We can also find what you can say like DLL and different. So this is generally to monitor the system resources, debug the software, and also detect the malware if then. So we can see if any kind of activity is going on or malware activity pops off, any kind of like malware search creates some activities on some processes, that everything we can see here. Process monitor, a genuinely beautiful verbose tool. So it's completely monitors the different system events. So as you can see in this picture, I will show you also later, you can see like what are the different processes were created here, right? You can see the results of you can see the PID details, and also even what is the command line, so what is the command that was executed. So like whenever, even if you run something from graphic user interface or whatever, you fire up any kind of command, right? So that command is generally what you can say, that command is you can see here AutoRuns. So AutoRuns is a tool that will generally scan the file system and registry for auto start extensibility points, so ASPs. So AutoRuns, we can check it out also. So generally malware, it adds itself to the startup location to enable persistence, right? So this utility has a generally, you can say, the most comprehensive knowledge of auto starting locations of any startup monitor. It shows you like what programs are configured to run during the system boot up or login, and when you start various built-in Windows applications like Internet Explorer and media players. So what you can say is that AutoRuns generally, so what you can do is like you can know, like for example, one may know like there are different ways the malware can hook into Windows, right? So there are a lot of ways for malware to hook into Windows auto start. So there are simple cases where the registry is modified to load modules on start, and or and like we can say, or anything else, like in some path or has been, startup path added. So there are more advanced techniques like a targeted drivers are loaded fairly early on the boot processes and are run with ring 0 privilege. So once you know the CPU architecture, you know ring 0 is the highest privilege. Microsoft generally only has two rings of protection, ring 0 and ring 3. So 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 the exam so one can say, or one, what you can do is like you can depend on Windows itself to load your model. So when a process loads library that are in their import table, they try a specific order of path to find the module they are looking for. So if you insert your DLL at a start location search before the normal DLL, this really just scratches the surface, but you get the idea that malware is creative and there are lots of ways for it to enable persistence. A lot of system process will load modules by default, and that's all the malware needs is a load, and then malware does its perform task, right? So this so using AutoRuns we get to know if some malware has been added in the system and see what you can, with behavior you can know and learn about its persistence. Rec shot I already explained. You take the two shots, compare it, and get your info. Capture bat. So capture bat, it only monitors that changes the changes that the malware makes to the Windows system. It generally can be also used to recover files that is dropped or that deleted by your malware. And finally, the fake net ng, I already told you. So it allows you to intercept and redirect all your specific network traffic. So it generally simulates a legitimate network services. So what is the benefit? We can The benefit is that the some malware, so you can know, like this malware or the exploit developer, they are becoming intelligent, and the more the malwares are also intelligent. So if we do or run these kind of thing in in a virtual environment or in somewhere the network is not there, the malware will not show it true colors. It finds a network is not there and it will simply drop it, simply just stop its functioning and not let us capture it. So it's getting pretty much smart so that it doesn't let itself get fished. So to capture that malware and get the network signatures, so we need to get the full malware's functionality, and for that we need to make believe the malware, yeah, this network is genuine even though it's a fake one. So that for that the reason the fake net ng, it helps. So going towards the Adelker's cryptocurrency miner, I already told you like how what's the history of Adelker's, how it came into picture. So generally Adelker's it is being to use mine Monero cryptocurrency. Monero, you can saw it's similar to Bitcoin, but it has really some good enhanced anonymity capabilities, right? It is has a much better algorithm. It's an open source cryptocurrencies, and it was created in 2014, I suppose, and it will purely focus on privacy and decentralization as other cryptocurrencies. So what you can say, the main thing is like it protects privacy in three ways. One, the ring signatures enable the signature sender to hide among other transaction output. It stealth addresses, it hide the receiving address. and it also hides the amount of transaction. So it's completely, it features a completely opaque blockchain. And so what the another highlight of this Monero is the egalitarian, what you can say is the egalitarian system. So it based, right? So this Cryptonaut is the technology that is behind Monero. And what this egalitarian mining process egalitarian is the egalitarian mining process made it like viable to distribute, you can say, the mining effort, opening so new funding avenues for both legitimate online publishers and malicious hackers so covertly embed the mining code into website and apps. So now what I'm telling is the Cryptonaut. So Cryptonaut is the technology that allows the creation of completely anonymous egalitarian cryptocurrencies. So and this is the real backbone behind the Monero. So in no, you can a number of community members have been focused, you can say, on research and development for on this for more and the current, what you can say, the current power distribution uh, uh, on our planet is the legacy of the world where the economy is controlled by few. And so the status quo was shaped throughout the centuries, so people engage in different things, have the full control. So that all, you can say, this all blah blah stuff. So it generated resulted in the state of art advancement in the technology, in the and cryptography, and that has been the key to these kind of crypto technology known like crypto note, which is based on the egalitarian system. So what is some highlights? So yeah, so it has some provides some difficulty for the miners and other. So the reason is like it retargets at every block, and that leads to some other highlights also, like untraceable payments, unlinkable transaction, double spending proof, blockchain analysis resistance, of course, you can say another good adaptive parameters. So these are some of the highlights of Monero. This the cryptocurrency malware, this idle curse. So it mines this Monero cryptocurrencies. So as I said, it compromises machine via eternal blue exploit and double pulsar backdoor. So, as I have already been saying about Adelker's cryptocurrencies and how these, they have been different kind of, hackers are using or miners are using. So this miner. So we have seen a rise in-browser cryptocurrencies. So like for example, like why this rise, like there was a rise in browser cryptocurrency mining malware. The first reason and the most important is like you, before I get to it, is like you to understand a couple of points. So like all websites have some operating costs, right? The more traffic the website attracts, the greater the cost. Many websites use online advertising to offset these kind of expenses, but there's, you can say, like, yep, it's not a good thing because surprise, surprise, people don't like ads. Yeah, and that's a brutal truth. With ad blocks, people are now trying to stop all these kind of unnecessary ads, and ad blocks are quite day of day increasing. Even browsers, new browsers, modern browsers are having inbuilt ad blocks. So with ad block users growing, like I think more than 30%, So in the last like 1 or 2 years, so web users are becoming more selective, like to what to click on. So naturally, these people are becoming more aware of adwares and other stuff, and they know like I shouldn't click on that ad that's going to pay the owner, or they don't want to click any unnecessary ad that want to redirect them, or even make their experience unpleasant. So they want to have a good nice glitch free experience when visiting a website without any unnecessary or inappropriate ads popping up. So it's harder than ever for website to sustain themselves using this advertising revenue alone. You won't believe me, but there were even like there are, you can say, or there were to be more precise, sites that were earning around $100 million in just ad revenue a year. So if this thing, they lose this thing, so what's the solution for them? So according to some website owners, the answer to their this issue lies in cryptocurrency mining. So a number of website operators have taken to exploit their users, like in order to pay their web hosting bills. And trust me, these web hosting bills are way too high. Even I am facing these issues. Like even if I want to get a dedicated server for myself, man, that's darn difficult. So I understand their pain, but I don't support this. So this number of website operators, they have taken to exploit their users, and now Monero is their currency of cryptocurrency of choice. So the reason behind Monero always being the cryptocurrency of choice when they try to use in browser attacks, the reason is that Monero is more optimized for CPU, but where the other, like its counterparts like bitcoins or other cryptocurrencies, they are more GPU intensive, like graphics adapter intensive, what do you call, graphics processor intensive. So see, what in case of Monero, thus people can do is like using JavaScript, they can manipulate the CPU more effectively than the GPU. So which these other cryptocurrency are unable for. So by injecting evil JavaScript code known as generally coin hive into their sites, these website operators, they are able to harness the processing power of website visitors and use it to mine for Monero. So this all things are generally done without visitors knowledge or consent, because no, unlike your what do you call, the conventional mining malware, this is a kind of breed of crypto jacking. So as it doesn't generally rely on your engagement, so you simply visit the website and your device is automatically transformed into a miner. Even if you heard like some past news and stuff, so like it was found out like the Pirate Bay, the like most famous BitTorrent slide, so it generally experienced some huge system drag. So it's actually, sorry, like some users of Pirate Bay, so when they were visiting the site, so they were experiencing some huge system drag. So the reason is like certain of Pirate Bay were used to no mine Monero. So and and people were the reason, the most thing that people were unhappy about, like this thing was done without their consent. So torrent freak, so it estimated the mining malware that could be netting this Pirate Bay, it was netting around $12,000 per month. It is not a figure to be just pass by or look at or sneeze at. That's really a huge amount. Yeah, even though it's just a small drop in the ocean to the comparing to the whole market, but yeah, but still it's a significant amount. So there are a couple of risk and ethics or legality people have, like who they are, these things are illegal, actually illegal. So all those comes to your consent thing. So see, the blockchain, even its backbone whole lies on the consensus, right? And here, like the people what we saw, not in more in the Western hemisphere, they found it was found like the people, their sentiment was that we don't have issue that they are using our CPU, or like it was used to mine Monero, but the main reason, because they were also especially for these websites. I am not telling you other malware stuff. About this website mining, they were not that much unhappy, because they said like, yeah, we are giving them something, we are getting something from them, some free site stuff, and in return, okay, they can take something. But the main issue was they wanted these things to be done in their consent, like the site or the website owners who you were trying to mine Monero using the resources of their user. They wanted these owners to first ask for their consent, and this to be, all these things should be made in their knowledge. And even some people really, they said like many said actually that they would have gladly opted if the, for example, in case of Pirate Bay, those admins would have been like been completely upfront and tell from the in a transparent manner, like, yeah, we are having issues to keep our site live, keep our site going, so we would require your resources to mine this malware, and if it would be great if you guys can help. So those people, they wanted this thing. So see, so this is about the sentiments and like ethics, whatever the thing. So like I will again repeat, like mining is not illegal. I repeat, mining is not illegal, but yeah, mining using different kind of malwares or bots, or in this kind of crypto jacking, that is illegal. So we see about the, like how to prevent your device from being hijacked or something malware in the later. So before that, let's go for some no. I saw about the working. So you can say like what the cryptocurrency malware does. So I think I have already explained you like what is the different acts of the malware are, and like exactly what it does. So the we can see there are a couple of I already discussed the working, like it infects by eternal view blue, and like moves laterally, like different thing. So the main acts of this malware, I can say, like malware is capable of performing the these all things, like it mines Monero, you as I said. It shut down SMB networking to prevent further infection with other malware, like the WannaCry worm or any other thing, by blocking the TCP port 445 in Windows firewall. It really degrades PC and server performance. It prevents access to shared Windows resources. It makes network connections to C2 server and sends public IP addresses, malware version, operating system, and architecture. Also, it sends CPU frequencies, number of processors, and memory size information of the infected machine. So basically, it sends all the resources, no, all the information of the resource that it's gonna use to mine the cryptocurrency. So it determines the public IP of the victim, download Monero cryptocurrency miner and additional tools, and make DNS requests to the Monero mining pool server. So after all these things, so it would like it downloads the mining instruction, and these instructions are then being used by the server to mine whatever the informations, and to in the what I can say in the no whatever the resource it has downloaded itself into. So now let's go and see about what else like we can see. Let's go and have some of demo. So everybody loves demo, right? I am going to use a Windows 7 system inside a virtual box. So that is my virtual environment where I'm going to try the malware analysis of the crypto miner called Adulcuz. So here is my malware sample. I have just changed the extension to .bin so as to protect myself, so that I don't by mistake just click and execute the malware on my system until I am prepared. So let's first start the static analysis. As you can see, this is the tool called PEStudio, which I have already explained. Here we can see there are a couple of things that this tool is showing us. It's doing the static analysis. So here we can see the virus total results. What this tool does is like it takes the hash value of this file, the sample, and it checks with the database of the virus total, and this is the result that it gets. So yeah, as you can see, there are a couple of these are all different AV antivirus engines. So almost all are showing, so yeah, you can see even some are showing that it's clean. Strange. So don't use these antivirus. So now it is taking time to show the indicators. So it would be having it would take some time. It would take to analyze different kind of indicators of this malware and give you executive summary. So as you can see, here is the DOS stub, the file header. You can see. So there are a couple of directories and then TL imports, libraries. So these are all the different DLLs that this malware is going to call. So as you can see, like two of these DLLs are already blacklisted. So these are the certain class imports that this malware will do. These are the entry point section entry points. So you can see different points with their hash values. Oh yeah, here the hash is available. Raw address is there. We can see the strings value. So whatever the strings we did. So for if we run the strings command that I had already explained. So these are all the info you will get. The overlay has come. So here is the hash values. So as you can see, the DOS stub is nothing. It will just show you a warning message that this program cannot be run in DOS mode. So this is what your generally the OS it checks, and so it will give you different kind of, it gives you the entropy values. It shows you what the hash is. So these are the different thing it will show you. So and no, generally what no, it's mainly for the DOS header. So that starts with your, as I explained, 64 bytes of every P file. So it's there because your DOS can recognize it as valid executable and can run it in the DOS stub mode. Okay. and it can be a full-blown DOS program. So when building applications on Windows, the linker generally sends some instruction to a binary called winstub.exe to the executable file. So this file is generally kept in some certain address, which is the offset to the next PE header. Okay. So the first few hundred bytes of a typical PE file are generally taken up by this this MS-DOS stub. Now, yeah, our indicators are already we have our indicators here. So you see, so there is like different scores are there from severity 1 to 10. As you can see, it's the color marks are also helping. So 1 is generally the highest severity, and 10 is for the lowest. Yeah, you can see the TLS callbacks here in the details. So these are some locations and the values. So what is TLS? So well, Microsoft defines TLS as thread local storage. So it's generally a mechanism that allows Microsoft Windows to define data objects that are not automatic, stack variables, yet are local to each individual thread that runs the code. So thus each thread can maintain a different value for a variable declared by using this TLS call. So generally this information is stored in the PE header. As I already explained, that PE header uses to store meta information. So a programmer can define a TLS callback functions, so which is generally designed to initialize and clear the TLS data objects. But from a malware writer or malware author's perspective, the beauty of this TLS callback is that Windows executes these functions before executing code at the traditional start of the program. So one may ask, like, how can this TLS callback is good for these malware authors and is no, it's not. So if this good for malware author, then it must be not good for your analysts or for your debuggers, right? Yeah, indeed. It generally confuses your debuggers and analysts. How? See, analysts often examine the malicious program's code by starting with some instruction located at entry point of executable. So the entry point is a field in pheader that stores your address in the first instruction in the program. So that Windows is generally supposed to execute. But debuggers typically take us to that instruction after loading the executable. And TLS callback functions allow malware authors to execute malicious code before debugger has a chance to even pause at this entry point, that is the general traditional entry point. So you can say, like, what the problem here is that even before the debugger has a chance to pause at any entry point instruction, it executes a TLS callback function. For example, say if you just if you load a certain for malware which employs this TLS callback technique into your debugger, and you expect the debugger to pause at its entry point, but instead your debugger seems to immediately say that the process terminated. So what just happened? Well, the result is obvious. You have infected yourself. So that's why this TLS callback, it's in the top priority. You can see different kind of other severity are there. So you see the timestamp, it's in the second severity. Can you see this time? This 1900. So I don't think anybody of us hearing this video would be would be there or present or be born by this year. So that's quite really fishy, right? Okay, so we have almost analyzed everything. So let's try to check it with another tool known as CFF Explorer. As you can see, it again gives us our normal general some property and values summary. It has hash, modifier time, creator time, p size, file size, export, import, TLS, directory. So section headers that I have already explained are data, e-data, different no resource data. So data, then TLS. So different kind of things are there. So hex editor, so here you can see it. So see here, if you can see in the hex editor, the first this, so they generally show you like exactly, you can see using this, generally we prefer using this much value to know that exactly the file characteristics. And here you can see MZ, so that means generally it's a P file, so portable executable file. So generally hex editor helps us to analyze, even if somebody has like here you can see I have changed the extension, but still the behavior or the original property of the file, the nature of the file doesn't change. So that you can check with the this hex editor. For say if the file is a GIF file, then it would be having PK. So here you can see the rebuilder. If you want to rebuild the p header, then using this you can rebuild. This is a quick disassembler if you want to disassemble the code. Okay, so that's all generally about the static analysis. So there are different kind of other tools also you can use for static analysis. I think we should move towards the dynamic analysis part, right? Okay, so before we go for the dynamic analysis, let me create a executable copy here. Okay, yeah, and like I explained, let's start a couple of things before I do the dynamic analysis. Yes, so my fake net is ready, it's running. So let me so I'm running capture bat. So as you can see, this capture bat, it generally I have explained you, right? So it would help me to do a couple of things. So let's try. So let me first create, let me start it with some, say I want to store my output so that I can even get whatever file or related file. So let me say, so I can get whatever the different outputs I want here. So it will store anything to my this output. So let me hard like, yeah, so first let me check it here, and here I don't have anything others in C. Okay, fine, that's a good. Okay, so let's start my capture bat. Okay, sorry. So you see, this is the problem you get if you run capture bat without an administrative privilege. So I just have to run it in administrative privilege. Right. So as you can see, you can directly start it in here also, or you can use this one to generally, if you want to, run it in something and store your specific files. So it is loading everything, file and stuff. So now let's start my process explorer. First process hacker. Okay, yeah, my process hacker is also ready. So now I need to take a registry shot before running my malware. See, different keys and values are being recorded. Yeah, you can see that it gave some results, right? So these many keys and values were stored. Okay, so I will keep the second shot after my infect with the malware. So now let's open one. Yeah, so I think generally all my things are ready. I have started my fakenet ng. I have started my capture bat, and let's start our malware. So remember, as I told you, my malware to be it would only it deletes itself, and so it needs your proper administrative privileges. So let's start with my malware administrative privileges. So as you can see, we are seeing couple of like some services being created, Windows event log management, and then like couple of CMD windows are popping up. Okay, so here my CPU, let's check. So as I'm infected with Cryptominer, let's see my CPU processes here. So it's just, as you can see, the memory usage is pretty much less. So my performance, you can see, just 1%. That's strange. Okay, so let's see what I have seen. So let's allow I can see something happening with my firewall. So it is changing something related to my firewall. So let's wait for some time, give it some time. It's still capturing and capturing. So generally, if you see, like in my virtual system, if I see my CPU, processor, wow, many things are going on. So you can see here my process consumption, or whatever resource consumption, what my task manager is showing is completely like zero, right? But is that it? Because as much we know, this idle cache or crypto miner generally consumes all your resources, right? So generally it was evident that idle cache no generally consumes all your resources, and it also detects the presence of task manager, like task manager.exe. If you run it again from here, let's open and if you run task manager.cxe, it's already opening now. So it checks the presence of it, and it will show you, like it can show that's normal system usage while the task manager is running in the background, right? But if you can no if you want to check it, like the what you can call, like this is usage the idle cache, so this one while the task manager.exe is running in the background. But that's not the fact. If you see, I can show you, like once I will run it, let me close it, and once I run task manager.exe, so you see the CPU usage was some high. So generally this what this idle cache is, it does, it generally detects the presence of task manager.exe and shows you normal system usage. If you can see, let me show you my real base system usage, and you can see, like yeah, almost 96, see the usage, the memory usage and the CPU usage, so they are being constantly being used. So that's the nature of the idle cache. It doesn't allow you to see anything. So I think we have left couple of time to for this to analyze. So let's first complete it. So stop my yeah, so I've stopped my capture bat. So in my process hacker, we could have saw like different of processes have been created, and if we go for the PC usage, so yeah, quite a different kind of processes has been created. Let us try to see for idle cache. Okay, quite a number of things are going on, right? You can see some really read and writes are going on, high read and writes. Okay, so you can, if you can check on all. So let's take the another registry shot of all the changes. So till registry is being, so let us take the registry shot. Wow, you can see like it's already captured. So let's compare now both the shots. Yeah, so as you can see, it shows us like 141 values were added to the registries, 32 values were modified, and like 40 keys were added. Nothing was deleted. So total changes were 213. So that gives a pretty much brief report about the registry changes. Okay, so now going for the process monitor, let us see. Category is, so let's see if any kind of writes are there. Yeah, you can see explorer.exe has set some registries. So these are different kind of file that were written. You can see quite of registry changes as we saw. Right, so let's check something, like let's filter and let us check that any operations was there or not. So operation is, I don't want this now. So operation is create. So to check any kind of process, create was there. Oh, sorry, I got a spelling. And then include, add. Okay. So now apply. Wow. So you can see here. Let me expand you. So you can see. So these are the different kind of process that was created. You see. So task manager sd manager.exe. So a task scale is there. Right. So you can see different kind of connection, the task scale MFC. So these were all done. You can see the different function that idlecus has done, right? So these are all, you can see anything that the idlecus has done. So these are different. So some creation was there, of like we saw the event creation or WELM. It was created, it was stopped, deleted. So these are the different changes that were done by the Cryptominer idlecus. So you can see here as I showed you, so stop WMLELM. So what generally that kill allows number of stub processes by invoking these kind of command line arguments through generally cmd.exe. And the first thing it did was killing sdmanager.exe, then mmc.exe, and also stopped the service we call WELM, and then you can see it has deleted it later, right? So if you can see here a couple of different kind of okay, so let's check it here properly. So as you can see, yeah, these are all different Edelgaz is doing small. You can see couple of changes it has done, right? Yeah, so these all are the different changes it has done. As you can see from the size to now affected the Chrome program. It has blocked stopped, and here you can see. So this was I was telling. So as I had explained that it what it does, that it some new firewall rules has been added by command line arguments, and this was the most interesting part. Was that the blocking of the 4454? As I said, that it doesn't, after it infects something, it doesn't allow further infection of the system by any other malware. Generally at that time it was WannaCry. So it generally restricts and blocks the port 445 SMB being exploited by any other malware, so that all resources will only be used by itself. Okay. So before, so let's say disconnect my network first for safety. So now I'm going to stop my fake net. Yeah. So packet capture has been created. So let's check which one I had in earlier. Okay. So this is the packet that your fakenet ng generated. So you can open it using Warshak or Tshack. So I am using Warshak on Windows. So yeah, you can see a couple of things here if you can analyze. Right. So let's check out a quick look through http dot request, because as I said, it generally tries to get instruction. So http request dot method question. So that what it does, it will check for any kind of get that it has done. Wow, as you can see, it has downloaded certain files, right? And let's check. So see, it has, so as you can see, the install and start. So let's check it. So following the TCP stream, you can see some user agent and using Lua socket. So let's again check. Yeah. So again this one. You can also, let's check for some other files also. You can see it has like mine.txt, the connection cross trail, and there. So looking at the get request, you can see different kind of get requests it has done. So different get requests it is doing. So as you can see, So these are the different. So if I try to export objects, so yeah, you can see that something from this host name super 5566 is being so you can see various, so these are different things. Mine, see, so yeah, so these are the application that were some downloaded from that site. So it is finally evident, so different thing that you know your malware was doing. Okay, so now we have seen the fake nets. So now, so that's all about the malware analysis of the crypto mining malware Adelkers. You can check for the capture bats logs, so that will give you the created, modified and deleted files. So these are the different things we find out. So we saw, like, that super 5566.com and couple and some 86.exe lua. So you can check all this, you can point us on all the evidence that you want, you can get from this packet, from the dump of fakenet ng, that is for capture bat, and using your process ProcMons. So that's all about the malware analysis. What I encourage all users and administrator is to adhere to some basic best practices, like huge firewall to block all incoming connections from internet to services that should not be publicly available, enforce a proper password policy, disable autoplay to prevent the automatic launching of executable files on network and removable drives, and try to disconnect the drives when not required. So if access is not required, enable read-only mode if the option is not available. So turn off file sharing if it's not needed. Turn off any unnecessary services, and if totally not needed, remove. So the best practice is always just keep what's needed. If it's not needed, remove it. So that's the best policy. So if generally a threat exploits one or more network services, disable or block access to those services until a patch is applied. So generally isolate compromised computers quickly to prevent threats from spreading further. Perform a forensics analysis and restore the computer using trusted media. There are a couple of more good best practices. So I shall explain it some other day. So that was all about the demo. So these are the different commands that have been run post infection that I showed you. So that's all, folks. Any questions? I think I have answered most of them, right? So thanks. Then, if none, thank you.
Hello, it's Anurag again. Hope you enjoyed this session. Please do share your feedback through the link which we have shared through the invitation mail. Your feedback is crucial for us to improve. IIS is a decade-old training institute offering all kinds of information security trainings around the globe. We have certified more than 10,000 professionals. Our subject matter experts are equipped with vast implementation and research knowledge. We at IIS are proud to call our trainings a workshop, as we believe in getting the participants hands-on. Once again, thank you for attending the webinar, and do join us for the next one, which will be announced soon. Thanks and have a nice day.